let's put in the magnitudes and the directions for all the vectors a, b, c, d here and do an actual calculation of us summing up these 4 vectors here. Okay, so I've listed down the magnitudes over here and I've provided the direction. All these are measured exactly to scale. Okay, so now if you want to sum of this vector, how we should do this is, let me bring this to the side. First, again, create an x and y axis. We still need some kind of pictures to guide us in doing our calculation. Okay, so this picture here, this xy axis together with all things labeled, will be a good guidance for us to do our calculation later steps. Okay, so what do we do now? We put all the vectors inside this xy axis, but we position the tail. Tail is this is the tail, this is the tail, this is the tail. We position the tail at the origin of the xy coordinates. Okay, so vector A here, I move it, I place the tail at the origin. Vector B, I place the tail at the origin. Vector C, I place the tail at the origin. Vector D, I place the tail at the origin. This is the first step. Place all the vectors that you need to sum up with their tail position at the origin of the xy coordinates. Okay, then after that, we move on to the process of resolving the vectors. But before we resolve the vectors, because there are many vectors here that we need to resolve, having a table is actually a useful tool for us to keep track of things. So I have here vector A, B, C, D, the x component and the y component. So we'll try to determine the x component and the y component for all 4 vectors here. Okay, let's look at the first vector, vector A. To resolve it, to avoid confusion I usually draw a squiggle here to show that I have actually resolved this. So those that I haven't squiggle means I haven't resolved it. It's just a way for me to keep track of things. Okay, so let's say now I resolve A, and because A only has x component, that's the only thing we have, AX. Okay, so now we have graphically resolved it. We have to change it into numbers here. Again, AX here is just the whole A, the magnitude of A, right? So you can just put in 8 meter here. But again, we have to be careful of the direction. Remember, resolve need to take care of direction. Pointing in the positive direction, positive value. Pointing in the negative direction, negative value. So this is supposed to be positive 8.00, which is the magnitude of vector A. Okay, for y component, since there's no y component for A, the y component will be 0. So we clear vector one by one. Once we are done with vector A, let's move on to vector B. Vector B, we want to resolve. We draw a squiggle. We resolve vector B. How do we resolve? Again, dotted lines to the x and y axis as we discussed last time. Then we will have our bx and by. Okay. If you can't understand what am I doing here, you might have to review the video on resolving vectors, which was earlier. Okay, so vector B here, we have to resolve it. This is graphically resolving it. Now we need the value. Again, for x component, over here, x component here, it's beside the angle. It's beside the angle, so it will be a cos theta. The by here, which is actually you can think of it as over here, by is opposite, so opposite will be a sine 30 degree. Okay, so we know x component here will be cos, but before we put anything, make sure the sign is included. Bx is pointing in a positive direction, so it's a positive. Then only put in the value. The hypotenuse 5.12 cos 30 degree. Cos because it's beside the angle. Okay, y component here is opposite, but let's check the direction. The direction is going in the negative y direction, so we should include a negative sign first before putting 5.12 sine 30 degree. Okay, sine is because it's opposite. Okay, now let's look at C. For C, if you want to resolve it on this diagram, graphically if you resolve it, we draw a squiggle, Then we draw dotted lines connecting to the x and y axis. Then we have our cx and cy. Now to put it into the numbers, let's look at cx first. Cx, it's right beside this 80 degree. It's right beside this 80 degree. So beside means cos. Okay, but again, we need to check the direction. This x is pointing in the negative x direction. So you should have a negative sign, followed by the magnitude of the vector, the hypotenuse, 11.2 cos 80 degree. Cos again because it's beside. Now for cy, can think of this arrow here actually being on this line, then it's actually the opposite side of the triangle. So it's a sine. So sine 80 degree, that's what you know. But remember the direction. The direction is pointing in the positive y direction. So it should be a positive sign, followed by 11.2 sine 80 degree. The magnitude of the vector c, followed by sine 80 because it's opposite. Okay, the last vector, vector d, resolve it by having a squiggle first. Then we draw dotted line to show that we are resolving. Then we get our dx and dy. Now put it into numbers. Dx is pointing in the negative x direction, so negative sign. This dx here is right beside the 40 degrees, right beside the 40 degree, so it should be a cos. So it should be 9.60 cos 40 degree. For the y component is pointing in the negative y direction, so negative. Then bring in 9.60. Then again, since this dy, you can think of it as over here, so it's the opposite side of the triangle, opposite sine. So 9.60 sine 40 degree. Okay, so this is the second step. The second step, we resolve the vector on the diagram. At the same time, fill in this table over here. Again, when you fill in the table, be careful of the sign. Be careful whether it's adjacent or opposite, then label cos and sine accordingly. Okay, that's the second step. Once we have done this already, technically we have finished the resolving process. Now what do we need to do? If you remember in the previous video, we bring all the x component to the x-axis, right? We bring all the y components to the y-axis. But in terms of calculation, what we actually do is we keep this table. We focus on calculating what's on the x-axis and calculating what's on the y-axis. Okay, so these are all the x components, these are all the y components. So actually what we need to do is just sum up all the x, then you get rx. You sum up all the y components, then you get ry. Okay, so let's straight away get into it. So ax, you just bring in the value, plus the value, plus the value, plus the value. You notice that everything is plus, but minus the negative sign is included in the table already. So when you're doing this summation, just add on everything. Okay? Then if you calculate all these things using calculator, you get 3.14 meter. Okay, for Ry, again, you sum up everything on this side of the table, then you get 2.30 meter. Okay, some of you might be thinking of straight away writing the answer of the summation down here. Well, yes, it's allowed as well, but I personally prefer to write an equation because equation shows really clearly what is equals to what. Okay, and some of you might be thinking, why don't I straight away calculate plus 5.12 cos 30 is what, then I straight put in my answer here. Well, I don't do that because later you need to round out your answer here. So when you round out your answer here, round out your answer here, round out your answer here, then your answer will be slightly deviated already. I prefer to keep everything without calculation first, then in one shot we do all the calculation in one line, get our final answer. Instead of round off, then at the end slightly deviated. Okay, I hope you get the idea. But we do it through more exercise. Okay, Rx here is 3.14, Ry here is 2.30. Both of them are positive value. So actually what does that mean? So if Rx is a positive value, means by Rx is pointing in the positive x direction. Ry, since it's positive, it's also pointing in the positive y direction. So now if you translate these numbers back into a diagram, it will be an xy axis with Rx pointing to the positive x direction, Ry pointing in the positive y direction. Okay, if you get a negative value for Rx, that means it's pointing to the left. If you get a negative value for Ry, that means it's pointing in the negative y direction. Okay, once you have known that, actually if you notice, this is the same arrow R and the same angle theta as the previous video, which we do it using geometry. Okay, but we are not done here. We managed to get Rx, we managed to get Ry, we still need to get the vector R, and the vector R consists of magnitude and direction. So now we want to determine the magnitude and the direction of this vector R. So in this diagram, we are actually trying to find the length of this arrow here, and we are trying to find the angle theta over here. We know from our previous calculation that Rx is 3.14 meter, Ry is 2.30 meter. Now to determine the magnitude of R, magnitude of vector R, we can try to rethink the situation over here. Let's bring Ry to this side over here. Then you can see that Rx, Ry, and the magnitude of R are actually forming a right angle triangle. So now if you bring this right triangle down, we can try to think. If I want to find the magnitude of R, and I have 3.14 meter, which is Rx, and I have Ry, which is 2.30 meter, how do I find the length of this side? How do I find the length of the hypotenuse side of the triangle? Well, it's just Pythagoras theorem, right? So Pythagoras theorem, we take this side of the triangle square plus this side of the triangle square, then we square root, then you get the length of the hypotenuse. Okay, so in this case it's Rx square plus Ry square, square root, then we get the magnitude of R. Now if you plug in the values, we will get the answer. The magnitude of R is equals to 3.89 meter. Okay, if your X or Y components happens to be negative, then you include the negative sign inside the bracket. After you square it, it will still be positive as well. So the magnitude of R here will always be a positive answer coming out, because the magnitude of a vector must be positive. Well, everything connects together well. Okay, just to remind again, this R here doesn't have a right arrow on top. This means this R here, it's a magnitude, it's not a vector. And because it's a magnitude, I can stop here without stating the direction. Okay, so this is the part for us to determine the magnitude. Now we want to determine the direction. How do we determine the direction? The direction, again, we need this value theta over here. Okay, so now if we put in our theta over here, we can label the opposite side as crossing the triangle. This is the opposite side. The adjacent side will be right beside the angle. And of course, this is hypotenuse. So to find the direction of R, we have opposite, we have adjacent. We want to find angle. Is it possible? Yes, we have our SOHCAHTOA, right? If you remember the TOA, it represents tangent, opposite, hypotenuse. So we have our opposite, we have our adjacent. We just need the tangent, theta. We just need the theta. So let's write the equation down. We know we will need tangent theta equals to Ry divided by Rx. So Ry is the opposite, Rx is the adjacent. So TOA, TOA, correct? Okay, but you notice here, I have included a modular sign for both Ry and Rx. So what does a modular sign do? A modular sign will remove any negative sign from the values inside here. So if it's a negative value, it will change it to a positive value. If it's a positive value, it won't change anything. Okay, why do I include a modular sign in here? It's because I want my angle to be a positive angle. Okay, if you include some let's say negative Ry or a negative value Ry or a negative value Rx, if we don't include the modular sign, there's a possibility that the theta here will be a negative theta. Then in that case, it might be a bit confusing, because usually we express all our theta as a positive value. We just need the value of the theta. We don't need the positive angle or negative angle. We don't want to complicate ourselves with all that. So I put a modular sign just to get a positive angle coming out. Okay, Now if we do our we move first. We move the tangent to the other side. Then it'll be theta equals to inverse tangent ry divided by rx. Put in the value. Then we key it into our calculator. We will get the angle to be 36.3 degree. So this theta here is 36.3 degree. So we find the length of this side of the arrow. Length of this arrow, we find the angle theta. You might think it's job done, but no. If you forget this step, you are technically incomplete. The last step of the summation of vector is to write out the vector itself, which means we have to write r, the vector, with its magnitude and its direction well expressed in words. Okay, because 36.3, no one's know whether this 36.3 is pointing which direction. This 36.3 here or here. So you need to express it in words. So writing down this magnitude here, do you notice I put right angle? Put a right arrow over here because I'm including the direction this time. Okay, so I write my angle, and this is above the positive x-axis. So I write above positive x-axis. Until this step, only I can consider myself to have completed the summation of these four vectors A, B, C, D. Okay, so it's a very long step. So let me sort of summarize the whole thing, what we have done throughout the last many minutes just now. Okay, so the first step is to place all the vectors, position their tails at the origin. That's the first step. The second step will be to resolve each vector on the diagram while filling up the x components and the y components in the table. When you fill in the table, make sure you check the direction, whether it's pointing in the positive direction or the negative direction. Check the direction. Then by determining whether you are obtaining the length of the opposite side of the triangle or the adjacent side of the triangle, you will determine whether it's cos or sine. Okay, today is a coincidence that everything is cos, everything is sine like this. But if I change my angle to the other side, then things will change. Okay, again, check if the length we are finding is beside the angle, adjacent, then cos. If the length that we are finding is opposite angle, then it's sine. Okay, so fill in the table. That's the second step. The third step will be using a table, determine Rx and Ry. So you sum up everything in the x component, get Rx. Sum up everything in the y component, get Ry. Okay, then once you have done that, using the value of Rx and Ry, draw a diagram for you to be clear where your R vector will be, where is your resultant vector. Okay, so all these steps here, finding Rx, Ry, and drawing it to visualize is the third step. Fourth step, using this diagram here, we determine the magnitude using Rx and Ry, of course, and we determine the direction. Okay, determining magnitude and direction, this is the fourth step. Okay, so the fifth step, the final step, will be to write the vector out by including the magnitude and the direction with the direction well described in words. That's the fifth step. Again, first step, place all the vectors with its tail at the origin. Second step, resolve the vectors in the diagram, then fill in the components in the table. Third step, sum up the x component to find Rx, sum up the y components to find Ry, then visualize Rx and Ry on the diagram like this. Fourth step, determine the magnitude using Pythagoras theorem, determine the direction using trigonometry, tangent. Okay, fifth step, write out our magnitude and direction with the direction well described in words. So that's how we sum up multiple vectors, or we call it as summation of vectors.